Here is the equipment setup for a double slit diffraction experiment using light polarization filters. The red laser will shine through the double slit polarizer and cast a diffraction pattern onto the whiteboard across the room. The double slit polarizer was handmade using imperfect polarization filters, so it was necessary to use a secondary polarizer to help clarify the interference patterns. Before we start, let's examine this pattern to remind ourselves what a double slit interference pattern looks like when no polarizers are used. Now we'll see how this interference pattern changes when we add polarization filters. This apparatus is composed of two pieces of polarization filter divided by a thin copper wire. By blocking the light, the copper wire creates two openings, two slits if you will. Each slit is covered with a polarizer so that the laser's light is filtered as it passes through the aperture. For the first experiment, both filters are horizontally polarized. This will allow virtually all of the laser's light to shine through both slits. If the horizontally polarized filter doesn't block the laser, how do you think the laser is polarized? This is the interference pattern produced using a double slit aperture with horizontally polarized filters. Now we'll change the aperture so that one of the openings is covered with a vertically polarized filter. Ideally, this filter would not allow any light to pass through, so that one of the slits was effectively blocked and light could only go through the horizontally polarized slit. But the filter is imperfect and some amount of light can still pass through it as we see here. The laser is shining through the vertical polarizer and the resulting dot is dim. Now the laser is moved slowly to the right. You can see it passing over the copper wire here. And now it is shining through the horizontal polarizer. The dot is much brighter because virtually all of the laser's light is able to pass through the horizontal polarizer. Now we will position the beam so that half goes through the vertical polarizer and half through the horizontal, producing the pattern you see here. Let's compare the three double slit patterns. What is the same and what is different between them? How does changing the polarizers impact the amount of interference we can see? How have our results been impacted by our equipment limitations? And what sort of pattern do you think we could see if we had access to ideal polarizers?